We try to solve illustrative example number 2. What are the first three terms of an arithmetic sequence whose 20th and 28th terms are 93 and 133 respectively? So, kapag kasi arithmetic yung sequence natin, we always want to know yung first term and the common difference. Here, in our case, ang binigay sa atin are two terms at yung kanilang respective positions. So, para ma-solve natin yung ganitong problem, we make use of the idea na ang arithmetic sequence kasi, so here's a trivia, ang arithmetic sequence kasi, pag ginraph natin yan, ang itsura ng kanyang graph ay isang line, at ito ay isang, at makakabuo nga tayo ng parang linear equation. So with that idea, we will form a system of linear equations to find the values of A1 and B. So we will use this formula. Okay, so here, we know the nth term 93 corresponds to the position 20th. So 93 ay 20th. So this will be replaced by 93, while this is replaced by 20. And 20 minus 1 is 19. So this becomes 19 times D. And this is A1 as is. While for this case naman, 133, this is replaced by 133, and here will be replaced by 28. So that's 28 minus 1, that's 27D. And then as is, this is A1. Well, we now have a system of linear equations, and we can use this system to solve for A1 and B. And we will do that by the process of elimination. So we are going to subtract the second equation from the first equation. At pag ginawa natin yon, mai-eliminate si A1. So pag pinag-subtract natin sila, mai-eliminate si A1. While here, we will obtain negative 8 times D. For this part naman, 93 minus 133, we'll get negative 40. So dividing both sides by negative 8, we get our common difference, which is 5. And then after that, pipili tayo between these two equations na siyang gagamitin natin. Ipa-plug in natin yung value ni D to solve for A1, A sub 1. So, we choose this equation. And then if we plug in 5 to D, we will solve for A sub 1, and that is negative 2. So now, we already know the values of A sub 1 and B. Then we can now find the first three terms of this arithmetic sequence. And that is si A1 ay negative 2. The next term, mag-a-add tayo ng isang 5. So we get 3. And then we add another 5, we get 8. So the first three terms are negative 2, 3, and 8. Clear? Alright. Now we review geometric series. A geometric series naman is the sum of sequence in which each term is computed from the previous by multiplying a constant, and we call it common ratio. So this time, ang ating keyword ay common ratio. The nth term a sub n of a geometric sequence is computed using this formula. So, si a sub n nako-compute by multiplying the first term by the ratio raised to yung position minus 1. Position ng term minus 1. So, A1 is the first term. And then N refers to the position. So, we have the following examples. So, paano nga ba natin nako-compute ang common ratio ng mga to? So, for letter A, to compute R, we divide 6 by 3. So, the common ratio here is 2. For the second example, we divide 5 by 5. So, the common ratio is 1. While for letter C, we divide 1/4 by 1/2. So, that is the same as multiplying 1/4 by 2. And what we get is 1/2. So, the common ratio here in letter C is 1/2. To evaluate the sum of a geometric sequence series, ito naman yung ginagamit natin na formula. Where N, this should be R, where R is not equal to 1. Or, kasi kapag R is 1, then ito yung ating formula na gagamitin. Hindi natin ito magagamit if R is 1 because magzi-0 yung denominator natin. 1 minus 1. Ngayon, meron naman tayong special type ng geometric series. And that happens when the ratio is between -1 and 1, excluded sina -1 at 1. We say that this type of series is infinite geometric and yung sum, it is given by a sub 1 over 1 minus r. That is if infinite yung ating series. But if it is not infinite and the ratio is between -1 at 1, still, ang gagamitin pa rin natin na formula ay ito. So, more examples later, more illustration later on infinite geometric series. Actually, it's already here. A popular example here is the infinite geometric series 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus and so on. So, parang you may think na, how am I going to evaluate or find the sum of such series kung walang katapusan yung pag-a-add ng terms? So, it's like, you may think that way. But actually, the answer here is 1. Kasi pag ginamit natin itong formula, that is to divide yung first term, which is 1/2, by 1 minus r. So, 1 minus, ano nga ba ang ratio dito? So, na-encounter natin yan kanina, at sabi natin ang ratio ay 1/2. So, this is 1 minus 1/2. So, so we have 1/2 over 1/2. A number divided by itself is 1, except when the number is 0. So, the sum here is 1. Pero, aside from using this formula, it makes sense din naman if we are going to make use of any sheet of paper para i-draw itong nangyayari dito. Imagine we have, excuse me, imagine we have 1/2 sheet of paper. And then, dadagdagan natin siya ng 1/4. So, ganito. And then, dadagdagan natin ng 1/8. Then, 1/16, 1/32, 1/64, and so on. If we continue yung process, alam naman natin that there's no way na lalabas sa 1 yung sum. So, if itutuloy-tuloy natin yan, mabubuo natin yung 1 whole. Kaya the sum of this, it does make sense that the sum of this is 1. Okay? Let's try to use the formula above to evaluate this series. So, obviously, this is an arithmetic series where the ratio is 2 because kita naman natin 3 times 2, 6 times 2, 12 times 2, and so on. So first, we want to know pang ilan ba si 3072 sa list. So, sa sequence, sa series. So we will use this formula to find the position, to find n. And kapag ginawa natin yon, what we will obtain is 11. So pang 11 ito sa list. Now that we already know that it is the 11th number, we will use this formula to evaluate the sum. So that is, ganito siya, and the value of that is 6,141. What if we want to insert numbers naman? So may mga ganitong items na na-encounter natin. What 3 numbers should be inserted between 81 and 16 so that the 5 numbers form a geometric sequence? So first, we compute the possible common ratio or ratios. So our approach here is we will let 16 be the 15th term, and then we will let 81 be our first term. It's like that because if we are going to insert 3 terms here, then para tayong may 5 numbers where 81 yung una, tapos si 16 yung panlima. So, using the formula for finding the using this formula, so ipa-plug in natin sina known values. So 16 is the 5th. So 16 equals 81 is our first term times the ratio raised to 5 minus 1, since n is 5, then n minus 1 is 4. Dividing both sides by 81, we get r raised to 4 is 16 over 81. At pag in-extract natin yung 4th root, we get positive or negative 2/3. Now, since our ratio can be positive 2/3 or negative 2/3, it means meron tayong 2 possible answers. We have 2 possible sets of numbers. And the first set is 54, then 36, then 24. While for the second set, negative 54, positive 36, negative 24. So both sets are accepted. Alright, for additional information, I included the Fibonacci sequence, and it is defined by a sub n equals a sub n minus 1 plus a sub n minus 2 for n is greater than or equal to 3, where a1 and a2 are both a1. So, yan yung Fibonacci. So, dinagdag natin. And we also included the harmonic sequence. Yan. At nabubuo ang isang harmonic sequence by getting the inverse ng terms ng isang arithmetic sequence. So, ito, pag kinuha natin yung inverses ng kanyang terms, may mabubuo tayong harmonic sequence. Ganun din ito kapag kinuha natin ang inverse ng arithmetic rather. Pag kinuha natin yung inverses, then meron tayong arithmetic sequence. na ang common difference ay 1/4. 1/2 plus 1/4, 3/4. 3/4 plus 1/4, 1 whole. 1 plus 1/4, 5/4. 5/4 plus 1/4, 3/2. So, I guess that ends my presentation. And if you still have, if you still want to know more or explore more, here are some practice exercises. Ayan. Ito. Pwede nyo silang screen cap or i-pause. And then, here are the answers. Alright. Thank you very much.